In lower course itself we have studied about Ohm's law. You know the statement of Ohm's law. At a constant temperature, current through a conductor is directly proportional to the potential difference between the ends. Now let us see. This is a resistance wire. So we are going to calculate the resistance of this wire using Ohm's law. So let us first see this. According to Ohm's law, at a constant temperature, current through a conductor is directly proportional to the PD between its ends. So I proportional to V or V proportional to I. So V is equal to a constant R into I. This R is called resistance of the wire. So R is equal to V by I. So using this, we are going to calculate the resistance of this wire. Resistance of the wire is equal to potential difference applied divided by current through the conductor. So current through a conductor is directly proportional to potential difference between the ends. So I proportional to V, or you can write V proportional to I. Then V is equal to a constant R into I. Here R is called resistance. R is equal to V by I. So using this, you are going to calculate the resistance of this wire. So let us see the circuit diagram first. This is a circuit diagram of Ohm's law. Positive of battery is connected to rheostat. Rheostat has three connection terminals, one at the top and two at the bottom. So here this is connected to the top. Then bottom two connection terminals are there. So from one side you are taking the next connection. It is connected to the positive of ammeter. The negative of ammeter is connected to positive of voltmeter. Then negative of voltmeter is connected to one end of plug key. Then the other end of key is connected to negative of battery. Across the terminals of voltmeter, we are connecting the unknown resistance. That's all about the circuit diagram. Once again I will explain. Positive of battery is connected to rheostat. The other end of rheostat is connected to positive of ammeter. Negative of ammeter is connected to positive of voltmeter. Negative of voltmeter is connected to one end of key. The other end of key is connected to negative of battery. Then across the terminals of voltmeter, we are connecting the unknown resistance. Now let us see the circuit here. Instead of battery, here we are using a battery eliminator. Then here is a knob to adjust the voltage. Then this is the switch of which, so on, then this off. Then voltage can be varied, so 2 to 12 can be selected. Then here I am selecting 4 volt, 2 or 4 volt sufficient. Then this is our key, this is key, this is the plug. Then positive of battery eliminator is connected to this terminal of rheostat. Rheostat has 2 more terminals there. So from the other end, you are connecting positive of voltmeter. Then negative of ammeter is connected to positive of voltmeter. Then negative of voltmeter is connected to one end of key. The other end of key is connected to negative. So once again, positive of battery eliminator is connected to rheostat. The other end of rheostat is connected to ammeter, positive of ammeter. The negative of ammeter is connected to positive of voltmeter. Then negative of voltmeter is connected to one end of key. Then the other end of key is connected to negative here. Then across the terminals of voltmeter, I have connected the unknown resistance wire. Then I am turning on the supply. The key is, see, the rheostat, this sliding contact must be in the middle. Then the key is closed now. Now I am going to perform the experiment. Before that, I am doing 5 trials. Then, so trial 1, 2, 3, 4, 5. Then the condition of Ohm's law is, if I send more current through a resistance wire, the wire gets heated. So the condition of Ohm's law is violated. So the current through the resistance wire must be minimum. So for that, I have the right to select the current. So I must pass only small current through the ammeter. So I am passing 0.1 ampere, 0.2 ampere, 0.3 ampere, 0.4 ampere and 0.5 ampere. So minimum possible current is sent through ammeter. Then by adjusting rheostat we can do that. So when I pass 0.1 ampere, so I can note the voltmeter reading. Then I adjust the rheostat. I will change the current to 0.2. In that case also I note the voltmeter reading. So one by one I take all the readings. Then I can calculate the value of resistance. Let us do the experiment. This is sliding contact. So sliding contact is adjusted. So you can see voltmeter reading and ammeter reading changing. See, both are changing. See, I am adjusting. Now ammeter reading is 0.1. Ammeter reading is now 0.1 and voltmeter reading is 0.3. See, during observation, your eye must be just above the reading to avoid parallax. So ammeter reading is 0.1, voltmeter reading is 0.3. So I shall note the value. Voltmeter reading is 0.3. Then I am again adjusting the rheostat. Now ammeter reading is 0.2. So there it is 0.6. So when ammeter reading is 0.2, the reading in the voltmeter is 0.6. Again I am adjusting rheostat. The ammeter reading is 0.3. There we are getting 0.8. Then again adjusting rheostat. Now it is showing 1. Then adjusting rheostat 0.5. Now it is 1.2. This way I am getting the values. Then I can calculate the resistance of the wire. V by I is the resistance, 0.3 by 0.1. So this way I can calculate the resistance wire. So I will get 5 values. I take the average, then it will be the value of unknown resistance. So once again I will explain. I have the right to keep the ammeter reading. So I can select the ammeter reading. So I am keeping the ammeter reading as 0.1, 0.2, 0.3, 0.4, 0.5 like that. Then adjusting the rheostat. In each case I am noting the values of voltmeter reading. Then I am taking V by I in each case. This is a V value here, this is I value here. V by I, you calculate, you will get the resistance value. Then 0.6 by 0.2, it will be the resistance here. 0.8 by 0.3, it will be the resistance here. Then I must get almost the same values here. Slight difference is allowed. So the average value can be taken. It will be the unknown resistance. Then suppose they are asking you, the examination, if they are asking you to do check series and the parallel combination of resistance, you can first use this wire. So perform the experiment using the first experimental wire. The same tabular column, the last column you write R1. So you calculate the mean value of R1. So mean value of R1 is not at. So some ohm you get. Then using the next resistance wire, you perform the same experiment. Then in that case, you draw the same tabular column. The last value will be R2. So you take the average value of R2. It will be some ohm. Then you connect the two wires end to end, and you will get a lengthy wire. Using that, you perform the third one. So it will be the resistance of the series combination, same tabular column. The last one must be RS. RS means resistance of series combination. So you will get the value. So RS, some ohm. Then you connect the wires parallel. Parallel means you take the first wire, you take the second wire. Ends are connected, and this combination is used there, placed there. See, the wires should not touch each other. Only contact is at the ends. In that case also, you can calculate the resistance. Then the same tabular column, the last one must be RP. So it is the resistance of parallel combination. So you get some ohm. Then you check. R1 plus R2 will be approximately equal to RS. So from calculated value you can prove it. R1 and R2 will be approximately equal to RS. This verifies series combination of resistance. In series combination, you know, if two resistors are connected one end to end, total resistance will be the sum of resistances. So R1 plus R2 will be approximately equal to RS. It shows the series combination is correct. Then next is you calculate R1 R2 divided by R1 plus R2. You calculate. This will be approximately equal to the answer of RP. Then it is proved that parallel combination is also verified. So in the first case you calculate R1, then next case R2, then wires end to end, then Rs can be calculated, then wires parallel, RP is calculated, then R1 plus R2. If R1 plus R2 is approximately equal to RS, series combination is verified, and if R2 by R1 plus R2 is approximately equal to RP, parallel combination is also verified. That's all about the experiment. Hope you understood. Thank you.